Okay, so for question 1, they tell us EFGHIJKL is a cuboid. A lies 2/3 of the way along KL, B lies 1/4 of the way along IJ, EF, EH, and EI can be represented by the vectors 6, -12, 0, 4, 2, -4, and 4, 2, 5, respectively. So they gave us this figure. The first thing I did is I placed the information from here on the figure in purple. So they told us A lies 2/3 of the way along KL. I put that, so on. We have three parts for this question, which is part A, calculate the components of EB, part B, calculate the components of EA, and part C, calculate the size of the angle AEB. So what I'm going to do here, I'm going to do question A and B together since they're very similar and we're going to follow the same steps, and we're going to then use the answers to question A and B to figure out the answer for question C. Okay, so in question A, we're trying to find EB, and in question B, we're trying to find EA. So for EB, we know it's equal to vector of EI plus 1/4 of vector IJ. So now it's very simple what we're going to do. We're only going to replace. So we know that vector EI is equal to 4, 2, 5 plus 1/4 of vector IJ, which is equal to 6, -12, 0. So now this is equal to 4, 2, 5 plus 1 times 6 divided by 4, which is 5.5, 1 times -12 divided by 4, which is -3, and 1 times 0 divided by 4, which is 0. And when we add them together, we get the answer, which is 1.5, which is 5.5 plus -1 plus 5. Now we're going to do exactly the same thing for EA. EA is equal to vector EH plus a vector HL plus 1/3 of vector LK. This is equal to 4, 2, 4, -4 plus 4, 2, 5 plus 1/3 of 6, -12, 0, which is equal to 4, 2, -4 plus 4, 2, 5 plus, so 6 times 1 divided by 3, which is 2, -12 times 1 divided by 3, which is -4, and 0 times 1 divided by -3, which is 0. And when we add them all together, we get 10, 0, 1. So our two answers are as follows. I've written on the board two formulas which we're going to use. This is formula 1 and this is formula 2. So the first thing I did is I used formula 1 to see how much EB dot EA is equal to, and I found 60 because we're going to need it in the next formula. And then I calculated the magnitude of EB as well as the magnitude of EA, and I got these two answers. Why I did this is because I wanted to use the formula cos A of B to find the value of A of B, which is what I did. So I calculated A dot B and the magnitude of A and B. I used the answers I received here. And then in the second step over here, what I did is I want to find AB. So I put the cos on the other side to get my final answer, which is 37.2. Okay, a cuboid measuring 11 centimeters by 5 centimeters by 7 centimeters is placed centrally on top of another cuboid measuring 17 centimeters by 9 centimeters by 8 centimeters. We can see the figure represented over here. They tell us the coordinates of A, B, and C, which is the most important thing to answer the question of finding the angle of ABC, the size of the angle ABC, which is over here. They tell us that the coordinates of A are 0, 9, 8, the coordinates of B are 3, 2, 15, and the coordinates of C are 17, 8, 0, 8. The formula that we need to find the angle ABC, which is going to be the vector BA dot BC over the magnitude of BA and BC. But we have none of the values, so what we're going to do is find the values. So for BA, we have to do the coordinates of A minus the coordinates of B, which are 0, 9, 8, minus 3, 2, 15. Those are the coordinates of A and those are the coordinates of B. The total will give us minus 3, 7, minus 7. We're going to do exactly the same thing for BC. C minus B, which is 17, 0, 8, minus 3, 2, 15, which will give us 14 minus 2 minus 7. Now that we found the value of BA and BC, we're going to do the magnitude of both of them. So BA is equal to square root of minus 3 square plus 7 square plus minus 7 square, which will give us a total of square root of 107. We're going to do exactly the same thing for BC, which is equal to square root of 14 square plus minus 2 square plus minus 7 square, which will give us square root of 249. We know that BA dot BC is equal to x1 y1 plus x2 y2 plus x3 y3, which is exactly what we're going to do. So this is x1, this is x2, this is x3, y1, y2, y3. So we do minus 3 times 14 plus 7 times minus 2 plus minus 7 times 7, and we're going to get a total of minus 7. Now we're going to apply the formula, which is cos of BA dot BC over magnitude, VABC is a pyramid with a rectangular base, ABCD. Relative to some appropriate axis, the vector VA is equal to minus 7i minus 13j minus 11k. Vector AB is equal to 6i plus 6j minus 6k, and vector AD is equal to 8i minus 4j plus 4k. They tell us some important information here, that k divides BC to the ratio 1 to 3, which I wrote in the figure, and they want us to find VK, which is this, in component form. Okay, there are two ways. We can either go VK is equal to VA, which we will take this root, plus AB, which we will then take this root and go to plus 1 BK. Or we can either use another root, which is VK is equal to VB plus BK. Okay, so I wrote over here a few important things. First of all, I'm going to use the root VA to AB to BK, and I wrote the component form of some vectors which they gave us previously. But here we have a little problem. We don't know what BK is equal to, but we're gonna figure that out now. So one important thing to note here is that vector AD is equal to vector BC and vector AB is equal to vector DC. So we know that BK is a quarter of vector BC. Vector BC is as well vector AD. So it is equal to 1/4 of 8 minus 4, 4, which is equal to 2 minus 1, 1. So now that we have BK, we already know what VA is and we already know what AB is. So all we have to do is replace. BK is equal to minus 7 minus 13 minus 11 plus 6, 6 minus 6 plus 2 minus 1, 1, which will give us a total of 1 minus 8 minus 16.